1D elastic and inelastic collisions. What is the difference between an elastic and an inelastic collision? An elastic collision conserves the kinetic energy, while an inelastic collision loses kinetic energy, so energy is lost. Therefore, with an elastic collision, we can use the formula kinetic energy of the system equals kinetic energy of the system prime, which just means that the kinetic energy before the collision equals kinetic energy after the collision. You can also use the conservation of momentum formula, which is total momentum of the system before the collision equals total momentum of the system after the collision. There's also a special formula, which is velocity of object A before the collision plus velocity of object A after the collision equals velocity of object B before the collision plus velocity of object B after the collision, which will make more sense once we start doing practice questions. A 2 kilogram ball going 4 meters a second rolls into another ball that's 16 kilograms going 1 meter a second in the opposite direction. What is the final velocity of both balls after the collision, assuming it's completely elastic? Okay, so let's do the first problem here. So I drew it out right here. So whenever you're doing a problem like this, you'd want to have a before and then an after drawing, so you kind of can keep track of everything. This is the before one right here. So I set block A to be the one that weighs 2 kilograms and block B to be the one that weighs 16 kilograms. So I have the velocity here. They're in opposite directions. So I'm going to make this negative because you can see I made positive in the right direction. Okay, so left is negative, so it's negative 1 meter a second. And this one is positive, so I'll just make this one positive there. Therefore, we can keep track of everything nicely in our equations. And over here we have after. Now we don't know the final velocities of any of these, so they're both kind of unknown. Here, I forgot to do the arrow there. So yeah, they're unknown velocities. We have the mass though. So we have 3 different formulas we can use. What I like to use is the first one and the third one. And then we're going to put the equations together to find our unknowns. Okay, so let's do the first one, which is potential energy, or sorry, not potential energy, total momentum of the system equals total momentum of the system after the collision. Okay, so I'll skip ahead to show what that looks like. All right, so I got the formula here. So momentum 1 equals momentum 2, basically. And then let's fill it in for all our numbers. So I'll skip ahead to show what that looks like. All right, so we can see this is what it should look like. So momentum of A at the start plus momentum of B at the start equals momentum of A at the end plus momentum of B at the end. And then let's fill in all our numbers here. So I'll skip ahead to fill in our numbers. All right, so I've filled in all our numbers here. Or I filled in all our variables that we know. Now we're still left with velocity A prime and then velocity B prime. So those are the 2 unknowns that we're trying to find. Anyways, I'm going to simplify my formula a little bit more, and then I'll show you the last one. All right, so that's the final step of this formula right now. So we can't really simplify it anymore without another formula. So we're going to write in another formula here, which is the third one that I was talking about before. So I'll just write that one in here. VA plus VA prime equals VB plus VB prime. Okay. And then I'm going to fill it in with all the numbers we have, and I'll skip ahead to that. All right, so I've filled in the formula here, and then you're just going to rearrange it. You can either solve for velocity prime, or velocity A of prime, or velocity B prime. It's up to you. I think I'm going to do velocity A prime. All right, so this is what you should be left with. So velocity A prime equals negative 5 meters a second plus velocity B prime. And now we're going to take this whole thing right here. So we're going to take this and we're going to replace velocity A prime in this formula with that one. Okay, so I'm going to skip ahead and show you what that looks like. All right, this is what it looks like now. So this is the entire formula we have right now. So then you're going to work the 2 kilograms into these 2 numbers here. So you're going to expand it out. And then after that, you're just going to simplify, or sorry, collect like terms, simplify, and then solve for velocity. Okay, so here I'll just skip ahead to show you what that looks like. All right, so we can see here I expanded the 2 kilograms into the formula So I got these two numbers right here, and then you're going to collect like terms. So that's going to go to this side. This is going to get added with that one. And then I'll show you what that looks like after. All right, and then this is what we get. And then you just divide by 18 on both sides. So we're going to divide by 18 here. Actually, 18 kilograms, sorry. We divide by 18 kilograms here. And then we divide by 18 kilograms here. And then the final answer you should get is 0.11111 meters a second. It's just 111 repeated on forever. So here I'll just draw that one in. So velocity b prime equals 0.1111, and then it's just repeated on forever. Okay, so I'll just leave it to like four sig figs and then meters a second. Okay, and it is in the positive direction because we can see 2 kilograms, which is positive. So which way do we set was positive? Right is positive. Okay, so it's going to be to the right. And then you probably don't want to leave that many sig figs. I'm just going to leave it just to show that it goes on forever, but you probably wouldn't want to leave that many sig figs. All right, so now we found the final velocity of B, but now what is the final velocity of A? So remember this formula up here, that's going to come in handy now. So, we're going to find velocity of A now, so A prime. So we're going to take this formula right here, and then we're just going to fill in for this value right there for velocity B prime, and we'll get our number, okay? So it's going to be VA prime equals -5 meters a second plus positive 0.1111 meters a second. And then your answer will be -4.88888888, right? So VA prime equals -4.8, and then it's just 88888 constant. So we'll just set it to 889, maybe. Yeah, we'll do that. Oops. So 889, and then after that, since it's negative there, so we look back up here again. So we say right was positive, so that means it's going to the left. So velocity of A prime is 4.89 meters a second to the left. So bracket left. There we go. And that's all you need to do for that question. So there's your answer, 1 and 2. So yeah, it's a lot of work. It's a lot of work, but it's not too difficult, okay? For inelastic collisions, the kinetic energy is not conserved, so we cannot use these two formulas. There's something called a completely inelastic collision, which is where the two objects completely stick together after the collision and therefore have the same final velocity. Let's look at an example of this. A stack of 5 shopping carts are pushed at 10 meters a second into a stack of 3 shopping carts. What is the final velocity of the shopping carts? Assume each shopping cart weighs 15 kilograms and the collision was completely inelastic. Okay, so I drew a picture here. So we have the before and the after. So we can see before, this is supposed to be 5. That's supposed to be 5 shopping carts, and it's multiplied by 15 kilograms. So it has a mass of 75 kilograms. It's a mass of 75. This one mass 45. Actually, no, yeah, sorry, 45. And then this one has a mass of 120. So 120. Oh, I didn't put in the 5. And 45. There we go. So that's the mass of all of them. And then, so initial velocity here is 10 meters a second, and it's in the positive direction, which is forward. And then final velocity is VA. Actually, it should be VA prime. So VA prime is the final velocity there. I just did VAB because they have the same velocity, so I can just put them together. And then velocity B is equal to 0 meters a second. So yeah, let's do the problem. So I'm going to put in our formula. So we're going to do P tote 1 equals P tote 2. So I'll just skip ahead to that. Yeah, so P tote equals P tote prime, which is just momentum at the start equals momentum at the end. So momentum before the collision equals momentum after the collision. And then let's fill in for all our variables. So I'll skip ahead to that. Okay, so this is what I get here. And then one thing to be noted here, so velocity b multiplied by mass b. So we can see velocity b here is equal to 0 meters a second at the start, right? So this we can just take out right away. That's equal to 0. So we're just going to set it to 0, and then we're going to take it away, okay? So I'm going to fill in all our variables now with all our knowns, and I'll skip ahead to that. Okay, so this is what it now looks like after we fill in the variables. So this is equal to 750, so that's 750. And then, so we're just going to divide by 120 on both sides, okay? So this is going to get divided by 120. This is going to get divided by 120. And then after that, we should get, so just plug this into your calculator. So 10 times 75 divided by 120, you should get 6.25 meters a second. And then of course it's also positive because every number here is positive, so it has to be positive. And then velocity, this is going to equal velocity AB, okay? So velocity AB like this, velocity AB prime. And then remember, so it's positive, so we look up here and look at that. See, forward is positive, so this is 6.25 meters a second forward. And this answer makes a lot of sense, right? Because it makes sense that it's forward because total momentum at the start has to equal total momentum at the end. And if it's all forward, then the final velocity is going to have to be forward, right? Or else they wouldn't be equal to each other. And then it makes sense that it's a little bit less than before because the velocity or the mass is now a lot larger, right? Velocity AB. I'll make this one look a little bit nicer. Velocity AB prime. There we go. And that's our answer right there, okay? So this one doesn't require as much work. It's a lot easier, right? Like the last one took like a bunch of lines of code, or a bunch of lines of, not code, but like formulas and stuff. This one only has like 4 lines. So a lot easier. Makes a lot more sense. Anyways, so that's all for this video. I'm going to have another one on 2D momentum soon. It's a little bit harder, but it's the same basic idea. So if you found this pretty easy, you should find the other one not too bad as well. All right, that's all.